me introduce our last but not least, of course, speaker today, Nick Goldsmith. Nick Goldsmith is the founding director of the Lightweight Structures Group at the ILEK company. Previously, he was the principal of the FTL Design Engineering Studio, a leading design firm specializing in membrane construction systems, where he was responsible for the design of membrane structures for around 45 years. He was managing partners of the FTL Happold for 15 years. But maybe what is most relevant for today to mention that after his studies, the Warmbron atelier at Frei Otto was his first job, where he was working from 1975 to 1977. That apparently influenced heavily your career. Stage is yours.
Thank you very much. And I hope you'll bear with me. I know it's been a long day. You've had a lot. And I'll try to be brief. And I also find it humbling to be here with so many amazing people who've known Frei. But I'll just talk today a little bit about my experience. And I really didn't know Frei Otto until 1972. There was an exposition in the Museum of Modern Art in New York, in the garden. This is the structure. Larry Medlin worked with Frei Otto in developing that one. And the book by Werner Glaser, The Work of Frei Otto, was the companion. When I saw that, although I knew Nervi and I knew Candela, as a student of architecture, this was completely new, and I was really just taken by it. I thought wow, this is a completely new direction. And, students love to go in new directions. So with colleagues at the university, I took it and kind of started saying, well, we can just build these things ourselves. So from Whiz Bang Quick City with Pete Seeger singing underneath one of our structures, we did polyethylene. We did woven polyethylene with tape. We built them in the evening at the university gym from about 11 o'clock to like 3 or 4 in the morning each night. We did concerts for Deep Purple, inflatable, just a series of different structures on the Art Squad using, standard stuff from the hardware store. Not really engineering, but we had the book of Conrad Roland, that original one in blue, that kind of talked a little bit about the form finding process and modeling, and we should have just kind of figured like we could just do it ourselves. And we did a little bit. So that was a lot of fun. And after finishing doing a thesis in lightweight structures, I came here, the space. This is, I think this is in 1976. And what you see here is Jamie Snyder, who's the grandson of Bucky Fuller. Bucky's there holding court, singing Rome, Rome for a Dome. It's based on the Home on the Range, American folk tune. Next to him is Sir Ove Arup. You have Frei Otto, of course. Behind Frei, as typical, you have Peter Strohmeyer. In front here with the Arabic headdress is Sami Angawe. And I'm over on the right, sort of standing out in the back. And Roberto Racconello, who used to work here, who's a professor, not a professor, he's an architect in Udine. Anyway, but what amazes me with just seeing this was that it was everybody there was such an incredible person and had such interesting things to share, and to be part of this scene. I knew it was special even at that age. So I worked for, I showed up, I had written to him, but he never really answered, which is fine. In those days, it wasn't, easy like it is today with texting and emails, etc. And I said I wanted to work, and I started out for about a month here at the Institute, just reviewing English translations for IL books, I think Giddeschalen and Noyes. And then he said, oh, I have a project for Scotland for BP. We need to do it at design and have it built in 2 months. So I was like, okay, you want to work on it? I said, sure. So that was the first project I worked on. We built these models, and what's fascinating about it was mentioned earlier, which I think was true, materials are really important. This is a coarse spun cotton poly blend, which really means that the whole cutting pattern on this thing comes through basically angle deformation of the fabric itself. So the only thing, we actually made the model, but Peter Strohmeyer went ahead and started fabricating all the panels out of straight panels, and we just patterned the edge of it as we went around, because that's really the only place, and the edge came later, and so it all came together. Queen Elizabeth opened up the North Sea, and about a year later, this showed up for the Silver Jubilee in Hyde Park, and I had a chance to see it in action. Another project that we kind of worked on, which was a lot of fun, was a Pink Floyd American tour in 1976. This is Ian Little, who is the engineer and designer of the Millennium Dome, and Jeffrey Wright from El Paso, who worked with us. So this was the mock-up. We did the drawings. The drawings we actually did full scale, 1-to-1. That was another really interesting thing for me to see. That's when you do that scale, you really check and find all the mistakes. And then I worked probably most of the time when I was there. I worked on this project called Kokomas, which was King's Office, Council of Ministers, and a Majlis al-Shura, which is a parliament building. And the idea was from King Khalid that if you had architecture, I think it goes back maybe to we heard earlier today, this notion of architecture comes and then sort of a culture follows. Again, this never really occurred. We did a design for about 2.5 years, but when Khalid died in 81 or something like that, the whole project went south. Anyway, an interesting project, and it basically was a tree structure project, so a branching structure. Here's the bowl itself of the Parliament building. There's started with that. We went to chain models, so small hanging chain models, and then we went to element net chain models, and then we went to perspex models. And one of the things that was fun, as you can see on the upper right, is Frei would always draw drawings of the modeling process before you were doing it. So it wasn't about how the building was, it was how are you actually modeling it, which was a really interesting thing. I never really thought of it. I said, what does it matter how you model it? You just want to get the shape for the final design, but it's not true. There is a lot of thought goes into that. I think this is an interesting, so he did this once as a sort of a sketches for me just to make me understand better these tree structures. And so he started out again with a sort of systematic approach, basically one tree structure, 3 tree structures and how they join together almost like a minimal surface, and then 6 tree structures. And what's fascinating with the 6 tree structures is as it opens up, it really becomes a dome in the center. And by then becoming a dome in the center and having these multiple tree structures, you're really creating a whole new typology. And, there's a direct, we talked today a little bit about a lot of precedents, whether it's Goethe or whether it's other types of, Freuble, but I think Gaudi is really an important one too that shouldn't be forgotten, because this really, to me, comes right out of, Colonia Güell and Sagrada Familia and a lot of other those chain hanging models. And, here are then kind of 3 different structures inside each other being pulled apart, building the model to hold those. And you can see down in the center, again, the 3 different models. So this one tree branching system is actually supporting this entire roof. And then the King's Office, which is sort of a more vertical version of the rest. And then taking that into section, hand sketching sections, the perspex model, and we had a local craftsman solder these together, and so then became presentation models. They were then chrome plated, and then finally shading systems. And we looked at about 6 different shading systems where we saw earlier that that sun modeling. This was really how we did it step by step with these different shading systems and looked at the sun pattern across. This was the Jeddah sports stadium. We built the soap film models, the fabric models. I think another thing that was really interesting is the fact that he would often set up the structure so that the columns only came in very late into the structure, that you realized where they were and you allowed them to sort of take, that sort of what it should be-ness, which is so important to Frei's approach. And this is then the double skin PVC polyester. I suspect, I never went to this one particular structure, but I suspect it's probably fairly hot inside it because just natural ventilation, no air conditioning in Saudi Arabia. My experiences there, I can barely survive in, the temperature and humidity. But anyway, finally, this is a project we did at Munich at the aviary. And here really it's kind of more about the material. We used a Tyler wire mesh stainless steel, but welded together in rolls. And what was really fascinating was sort of the detail. Generally you'd always do a ring structure or something where you hold up a membrane and have columns coming through it. But here he kind of develops this sort of pin plate system, which acts as a ring but has flexibility and it's very light. And so as a result, you basically almost don't see the ring that runs around it. It just fits right into the mesh itself, whether it's obviously not in snow, but whether it's in from above or from the side or from inside. You really don't see it. So as a mentor, those were kind of the formative parts. I then kind of went back to New York and, wondered what our relationship would be, but he asked me to do a show in New York for him and things like that. And we became more of a colleague. And so when I founded FTL Design Engineering, it was about 45 years I had that. Or 10 years we were a joint venture with Bureau Happold called FTL Happold. We were completed about 500 lightweight projects. And then recently the studio joined T.Y. Lin. So I will just show 5 projects that kind of feel like it really had the influence of Frei in so many ways. And I wasn't sure why I was going to put this image on, but then after people said, did Felix Candela and Frei Otto actually meet? So yes, this is a picture of the two of them there. This was in 95 or 96, maybe 97. It was before Ted Happel passed away, so I probably might have been 96. But anyway, we had sometimes design reviews where we could kind of meet with them, and with Frei was very willing and to share his thoughts. And a really generous man. I heard a lot of stories, but I never. But my own experiences were really of incredible generosity. First project. This is one that I did show here just before he retired, or at the time of his retiring. It was basically a traveling music facility that has no foundations other than the concrete inside the trucks themselves, and it goes to 21 locations per summer, and it's a full orchestra, so full concert orchestra with choral risers, and goes around the city. So there are basically 4 main semi trucks, and then the other trucks that go with it. And it's really a puzzle project, where how do you put it together? The whole thing has to really kind of come as sections. It self erects with little hydraulic outriggers, and it has a trolley that opens up. It joins the rear truss, then pushes up the other two. The fabric comes from the center. All of the different pieces are kind of there. The outriggers, the stage folds out in a half an hour, etc. And it just sort of, how do you fit all of that onto these trucks? And that's kind of like the main part of it. But I think Frei was fascinated by the fact that you could kind of get it all together, and still the shape is the one thing about Frei, from an architect's point of view, we talk a lot about structure, but Frei's 10 structures, they're all absolutely beautiful. There's an aesthetic, and you could do the same, and have the same strength, etc. But there is an aesthetic in all of them, and that was something that, for me, I've always liked. You can tell the difference. There's no question which one's his. This was a project about grid shells. where we were given sort of a shape by an architect. We then kind of turned it into something that was more of the process of form finding, you know, so looked at it more as a toroid shape, and then kind of opening it up in digital versions. We did it as catenoid, we did it as a toroid. We ended up going with a toroid, even though the catenoid had lighter member sizes, but we basically, it was much cheaper with the different radii. So and then we looked at different size openings for the geometry, and then looked at kind of how the detailing of it was. And we then decided, in order to have the pillow system, because it's an ETFE enclosure, we wanted the pillows to run continuously. And so we dropped the lower part of the grid shell. It becomes kind of more like a frame structure. It has LED lighting on the top with a fritted edge to it. We have basically the air comes through the structure itself. So the steel is then inflated, and you just have leashes with inflation for the pillows. You can see here the installation. This is kind of the structure from the parking area, walking up, and looking from the entry going out. And different at night, of course, because it's an LED system, you can change the colors of the lights, etc. And you can, and this kind of showing you it's going across the structure. As a more classic tensile structure, again, this idea of like, what is something that really feels like it's lifting from the ground. There's a wonderful dancer that was an American dancer in 1900 in Paris called Loie Fuller, and you can look at some of her dances on the internet. She had wood extensions on her arms, and had fabric that she wrapped, and had lights, oil lights underneath. And basically, she danced and made these kind of amazing structures. And I was trying to think, how could we do something like that with tensile structures, working with physical modeling and digital modeling. And what's interesting about this to me was that it's a rotational geometry rather than a reflective geometry. So it's not a geometry that has a static line at some point doing it. And this is the structure in Scottsdale, Arizona. It's about a 6,000 square meter structure at the center of the campus for Arizona State University. And, they can see, I'll go on. For one of the inspirational qualities about this space here with the cable net and wood, this is a project in Sun Valley. It's a project which had 1,000 kilos per square meter of snow load on the roof. So it had to have a pretty robust roof. And we basically used a cable net with wood based on this kind of approach. And also the high par shapes are wonderful acoustic shapes. So we used it as a way of really blending sound. And so we came up with a winter and a summer version of it. The winter one is the permanent cable net roof. The summer is just a seasonal fabric, which kind of made sense. Again, have the structure where you need it. But the winter one had to have all the infrastructure for a theater. So again, the acoustic elements that are used in the theater, the volume of air, which is critical, the physical modeling of the shape itself. This is now the steel trusses. It's the cable net itself that sits in the steel trusses. The clamping system for the cable nets. And then basically what we used here was like wood sleepers that kind of set on these shoes that fit on each node. And then the wood sleepers then had a shiplap dug fir, and then insulation and the roof on top of it. And this basically is kind of showing the one-day install of the fabric. It just gets kind of lifted up and put into place. All of the steel work is there. Basically, it gets into shape pretty quickly. The interior of it, when it's operational, entry of it, and from the lawn, there's about 3,000 seats on the lawn. I think about 2,000 seats inside. So medium-sized amphitheater structure. Finally, this one is kind of a hybrid design of different things. So I thought this was certainly one that, because one of the things I always enjoyed about Mannheim is that he tried to use different types of connections to see how they worked. So it isn't just okay, this is the design, I'm going to do it everywhere. But how do you learn from it in that sense? And this is basically it's about a 400-meter long bridge. It joins the two Microsoft campuses together. Just opened last year, and it has separate bike and pedestrian lanes, and it covers about 20 different lanes of traffic and a light rail system. Starting with kind of concepts of how we develop it as a series of pedals and how the light rail station works, and again, going from digital into physical, back into digital modeling, looking at wind tunnel modeling. Again, you have part of it as an arch frame system, and part of it is a tensile conoid structures. So it's kind of a combination of things, looking at, of course, the fabric stresses, the cable forces, the loads, the details, which again is an important part of it. Yep. We'll bring the water down. You can see here the pedestrian and the bike lanes. Bringing the water down becomes kind of a feature point. You can't have water coming off the bridge, so basically you basically have to contain all the water that's on the bridge. So we used cisterns and irrigation systems, and we collected all the water with a gutter edge, with downspouts, bridge itself, and walking through it with the landscaping. It's kind of a place you can stop easily, go through it, stop at any place. It starts out narrow, and then it opens up, becomes larger, as it crosses the bridge. You can see the sort of seating areas, the joints. This is kind of the downspouts. Tried to speed it up a little. So anyway, and then of course there's expansion joints. And that's it. And I thank you very much for listening. And this was the last image that I have of myself with Frei from 2014.